Welcome to EC Elimu Learning Simplified and welcome to this lesson. In the previous lesson, we discussed how to determine the center of gravity of different shapes, either regular shapes and irregular shapes. Now in this lesson, we are going to discuss some of the problems which involve determining the center of gravity. My name is Albert. I hope you will enjoy the lesson. By the end of this lesson, I expect you to be able to solve problems involving center of gravity, and in this case you will need some ideas from the previous topic, that is the principle of moment. So the question reads, the figure below shows a uniform metal rod of length 20 meter and weight 25 Newton in equilibrium. Determine F. So in this case, the first thing that we need to take care of here is that the metal is uniform. Uniform means its weight is evenly distributed, even its center of gravity will be at the midpoint of this metal rod. So if its length is 20 meter, therefore it means at its midpoint, that is 10, that's where we have the C or G. And if its weight is 25 Newton, then it means at the 25, that at the 10 meter, that is where the weight of 25 Newton acts. So this way we'll have our 25 Newton. So if it's at equilibrium with all these forces that we have, then we can determine F by using the principle of moment, that is clockwise moment is equals to anti-clockwise moment. So in this case, what we will do, we will determine the forces which will give this meter or this rod a clockwise moment. And in this case, the 25 Newton, this is the pivot here, this is the pivot. So this 25 Newton of this rod will give it a clockwise moment. Then this 100 here will give it a clockwise moment. Then we have the force F will give it an anti-clockwise moment. Then this force of 240 will also give it an anti-clockwise moment. So in this case, we have two clockwise moments and two anti-clockwise moments. So let's label these forces. This weight of 25, let's call it F1. Then this one of 100, let's call it F2. Then this one here, let's call it F3, the F that we are looking for, F3. Then this 240, let's call it F4. So in this case, if we use the principle of moment, then clockwise moment, that is F1. Then the distance from the 25 where we have F1 to the pivot is 10 minus 6, that is 4. Let's call it D1. Then D1, which is 4 meter. Then the second distance, that is D2, is from 20 to 6. That will be 14 meter. That is D2 in this case. So D1, F1 D1 plus F2 D2 will be equals to F3. F3 in this case is what we are looking for. F3 D3. D3 in this case is from 0 to 6, this distance here from 0 to 6, so this 6 meter. Then now times F4 D4. F4 D4. D4 is from 2 to 6, it means this is 4 meter. Then in this case, if we substitute with what we have here, F1 is 25 Newton times D1 is 4 meter, then plus F2 is 100 Newton, then D2 is 14 meter. These are clockwise moments. Then they should be equals to anti-clockwise moment, that is F3 times D3. In this case, D3 is 6 meter plus F4, that is 240 Newton times D4, which is in this case 4 meter. So in this case, if we can solve this one, then it's going to be 25 times 4. 25 times 4, that is 100 Newton meter, plus another clockwise moment that is 14 plus 100, which is the same as 1400 Newton meter. Then it should be equals to anticlockwise moment, that is, we have F3 times 6, so it's going to be 6 meter F3 plus, then we have another anticlockwise moment, that is 240 times 4 as the distance, which will be 960 Newton meter. So in this case, for us to get F3, which is the same as the F that we are looking for, then in this case we will add the total clockwise moment, which will be 1400 plus 100, which will be 1500 Newton meter, is equals to 6 meter F3 plus 960 Newton meter. So in this case, like terms together, we will bring this the other side, then we will remain with 6 meter F3 is equals to 1500 Newton meter minus 960 Newton meter. So in this case, if you have 1500, you subtract 960, what you will get is 540. So in this case, our 6 meter F3 is equals to 540 Newton meter. And now for us to get F3, you divide by 6 meter on both sides, 6 meter. Then in this case, the 6 meter will cancel on the left hand side. Then we will remain with our F3 is equals to 540 divided by 6. Then it's going to be 90 Newton, because in this case, meter will go with meter. 6 goes to 540 90 times. So in this case, you will have calculated the F that they are looking for. So in this case, you can say F is equals to 90 Newton. Another question, the figure below shows a uniform metal bar of length 50 meter in a balanced condition. It means it's at equilibrium. Determine the weight of the bar. What is important here, the keyword is a uniform metal bar. When you see a uniform metal bar, it means it is symmetrical and therefore its weight is balanced and the center of gravity, or the COG, is at the midpoint of its length. Like in this case, if it ranges from 0 to 50 meter, then it means its center of gravity will act at 25 meter. And at 25 meter, that is where its weight acts. That is the COG. This is the COG. So this is where the weight of this metal bar will act. So in this case, if they want us to find the weight of this metal bar, then we have some forces on the right hand side which will give this bar a clockwise moment. Then in this case, the weight of this bar is the one which will give it anti-clockwise moments. Like in this case, the one which will be pushing on this side is the only one, that is the weight, which will give it an anti-clockwise moment. Anti-clockwise moment. Then the weight of 200 Newton will give it a clockwise moment. Then the one with 100 will give it a clockwise moment. So in this case, if you use the principle of moment to determine the weight of this rule, then it will be sum of clockwise moments is equal to the sum of anti-clockwise moments. And in this case, how many clockwise moments do we have? We have 1, 2. Then now, how many anti-clockwise moments do we have? We have only one anti-clockwise moment in this system. So in this case, if we call this weight F1, then the distance from the pivot, that is 35 minus 25, which is D1, let's call it 10 meter. Then if this force of 200, we call it F2, this is our F2, and the distance from the pivot, we call it d2, and in this case it is 40 minus 35, which is 5 meter. Then the distance from the force of 100 is 50 minus 35, which is 15 meter. And then the force, we call it F3. Then in this case, the forces which will give it a clockwise moment is F3 and F2. So in this case, F2 D2 plus F3 D3, these are clockwise moments, will be equals to anti-clockwise moment, that is F1, which is the same as the weight, F1 times distance 1. So in this case, if we replace the clockwise moments with F, we replace with the forces that we have there, then in this case, it's going to be 200 newtons times D1, which is 5 meter, plus another clockwise moment is 100 Newton times the distance is 15 meter. These are clockwise moments. Then they will be equal to anti-clockwise moment, that is F1 times the distance from F1, that is W, to the pivot is 10 meter. So in this case, if now I replace all, I solve on the left hand side, then it's going to be 200 times 5, that is 1000. So in this case, there will be 1000 Newton meter, plus 100 times 15, that will be 1500 Newton meter, will be equals to anti-clockwise moment, that is F1, which is in this case the same as our weight. So it's F1 times F1 multiplied by the distance to the pivot, that is 10 meter. So in this case, if we add the clockwise moment on the left hand side, it will be 1500 plus 1000, then it's going to be 2500 Newton meter is equals to 10 m. Let me use the green pen for consistency. So here it's going to be 10 meter F1. Then in this case, if we need F1, then we will divide by 10 meter on both sides. Then in this case, our F1 is going to be 2500 Newton meter divided by 10 meter. So in this case, meter will cancel with meter, then this 10 will take 10 at the top there. Then we will remain with F1, which is the same as the weight of the meter rule, as 250 Newton. Another question reads, the figure below shows a uniform plank of weight 20 Newton and length 6 meter balanced by a 0.5 kilogram mass at a distance x from the pivot point O. Determine the value of x. So in this case, the keyword here is a uniform plank. Uniform plank means its weight is balanced throughout, and therefore its center of gravity is at the middle of this bar. So in this case, if we have from 0 to 6 meter, then at 3 meter, we have the center of gravity. This is the COG. And at the center of gravity, that is where the weight of this plank will act, that is 20 Newton. Then now in this case, if we let's call this one F1, that is the first force. Then on the other hand, we have 5 kilogram. 5 kilogram, we can change it to force by weight, which is the same as force is equals to mass times gravitational field strength. So in this case, we have 0.5 times 10, it's going to be 5 Newton. So here we will have F2 as 5 Newton. Then now the distance x from the pivot, that's what we are looking for. And then if we need the distance of F1, that is the weight of this to the pivot, then we also don't know it, but we know the distance from 3 to 6. From 3 to 6, it is 3 meter. And now from this center of gravity to the pivot, it is 3 meter minus this distance x. So that's what we are going to use. That's our d1. We call it d1. Then this x is going to be d2. Then in this case, if we use the principle of moment, sum of clockwise moment is equals to the sum of anti-clockwise moment. Then in this case, we will write as clockwise moment here. It is this force of 5 Newton, which is produced by a mass of 0.5 kilogram. This is the one which is clockwise moment. This is the one which will give a clockwise moment. Then the weight of this plank will give us an anti-clockwise moment. So in this case, the clockwise moment that we have is F2. Our clockwise moment will be F2 times the distance of the pivot, that is D2, which will be equals to F1 times the distance to the pivot, that is D1. But in this case, F2 is 5 Newton, then times distance to the pivot is x. This is x. That is the distance to the pivot. Then now it should be equals to, this is x as a distance. Then it should be equals to F1, which is 20 Newton, times the distance to the pivot, that is 3 minus that distance x. That is our D1. So in this case, if we solve the left hand side, then it's going to be 5 times x. 5 Newton times x is going to be 5 Newton x. This is not a multiplication, it's an x. Then is equals to, on the left hand side or on the right hand side, now we have 20 Newton. Then if we open this bracket, it's going to be 20 times 3, 20 Newton times 3 is going to be 60 Newton. Then 20 Newton times negative x is going to be minus 20 Newton x. Then now in this case, we have common factors, that is Newton x and Newton x. Then we are going to bring 20 Newton x to the left hand side. Then what we are going to get is 5 Newton x. Since this one is a negative, when it comes, it will become a positive. Then it's going to be plus 20 Newton x, plus 20 Newton x. Then it's going to be equals to 60 Newton. It's going to be 60 Newton meter. Remember here, when we multiplied 20 Newton times 3, it's going to be Newton meter here. It was Newton meter. So it's going to be 60 Newton meter. Then in this case, 5 Newton x plus 20 Newton x is going to give us 25 Newton x, which is equals to 60 Newton meter. Then now for us to get the value of x, then we will divide by 25 Newton on both sides, 25 Newton. Then in this case, we will remain with x is equals to, Newton will cancel out with Newton. Then our answer will remain in meter. And in this case, 60 divided by 25 is going to be 2.4 meter. So the value of x is 2.4 meter. And if you want to know the value of the center of gravity to the pivot, then you will take this equation here. That was 3 minus x. So if you want to know the distance from the pivot to the center of gravity, it's going to be 3 minus x, which is in this case is going to be 0.6. But this one is the distance d1. But here we are looking for d2, that is equals to x. So our x is 2.4 meter. So now you can handle the last question as an assignment. And if you get any challenge, feel free to visit EasyElimu Learning Simplified website for more questions and solutions on this. So that marks the end of our lesson today. In the next lesson, we will discuss equilibrium and the states of equilibrium.